VLAN routing. So after understanding what VLANs are, the next thing you need to understand is how we can route packets from one VLAN to another VLAN. Because when we create VLAN, we logically isolate end devices. Therefore, devices on VLAN 2 cannot be able to communicate with devices on VLAN 3. But what if we wanted them to be able to communicate? That is where VLAN routing comes in. So the implementation of VLAN technology within an enterprise network effectively establishes broadcast domains that control the scope of traffic. One of the limitations of broadcast domains is that communication at the link layer is hindered between hosts that are not part of the same VLAN. Traditional link layer switches supporting VLANs are not capable of forwarding traffic between these broadcast domains, and therefore routing must be introduced to facilitate communication. The application of VLAN routing when using link layer switches together with a device capable of routing VLAN traffic is introduced, along with details of how layer 3 switches capable of network layer operations can enable communication over VLAN defined broadcast domains. By the end of this chapter, you should be able to. Bethwell, you can help us?
Explain the purpose of VLAN routing. Explain how VLAN routing is achieved for layer 2 and layer 3 switches.
Yes.
Configure VLAN routing.
Okay, thank you. So generally, as we must have seen already, when we create VLANs, we isolate users on layer 2. So users that are on VLAN 100 and users that are on VLAN 200 cannot be able to communicate. Why are we creating VLANs? In an attempt to limit the broadcast domain size. I want the broadcast domain to be a little bit smaller so that we can avoid causing congestion in our network. But what's the problem with this strategy? It isolates users. So what's the solution to this? It requires a layer 3 device in order to establish communication between these two between devices on these two VLANs. So let's see. When we talk of layer 3 device, we talk of IP. They forward using IP. So let's look at how this can be done. So after the VLANs have been configured, so for example here, we have host A on VLAN 2 and host B on VLAN 3. After that has been configured, they cannot be able to communicate. If they need to communicate, as you can see by the arrow here from host B to the switch, they need to go to a layer 3 device. The layer 3 device can be a router or a layer 3 switch, as we're going to see. So that particular frame has to be sent to the router packet, then sent back, and eventually to the switch, and eventually to host A. So VLAN frames are routed over a trunk link, for port conservation. So what does this mean? In particular, we have several options. The first option is we can use one interface for one VLAN and another one for the other VLAN, like that. But this will lead to what we call port wastage. Sorry. It will lead to port wastage of ports, because most layer 3 devices have fewer ports, and the more the number of ports, the more expensive. So port wastage. So in order to conserve ports, we can use the same physical interface, and we subdivide that particular interface, as you're going to see, into what we refer to as sub-interfaces. Okay, so as I said, this can be a router or a layer 3 switch. A layer 3 switch can perform functions that switches can perform, and also functions that routers can perform. So let's look at how this is actually done. So the very first thing you must understand is that a single trunk supports VLAN routes by using sub-interfaces. So what does that mean really? So we have this interface here. Which we must configure as a VLAN trunk, as a trunk link. And now we can be able to subdivide this into two sub-interfaces. So we can be able to subdivide this into two sub-interfaces, something like that. And when you do that, each sub-interface must be assigned an IP address. Each one of them must be assigned an IP address that is within the network range for that particular VLAN that it's trying to connect to. Sorry, I've just pointed to the gateway address, but what I'm saying is, let me just type it. So if this is, let me clear. So you see, we are subdividing an interface G/0/0/1 into 1.1 and 1.2. So each of these sub-interface has to be assigned an IP address. So as you can see, really, the network address for these particular devices that are on this VLAN here, they didn't write it, but it should be 192.168.2.0/24. So that is the 2.0/24 network. On the other hand, this one here is on 192.168.3.0/24 network. So what I mean is that each of these sub-interface should have an IP address, should be assigned an IP address that is within that particular network range that represents that particular VLAN. So that is important to understand. And this particular port here can either be a trunk port that interconnects the switch and the layer 3 device. It must be configured either as a trunk or a hybrid, or a hybrid port. So let's see how that is done. So in this particular example, we have host A here, who is in VLAN 2. So we've added that interface to VLAN 2. Host B is on VLAN 3. So this interface that is connected to host B is on VLAN 3. Then we have switch A and router A here. So we want to configure. So we'll start by creating VLAN 2 and VLAN 3 using the command VLAN batch 2 space 3. Then we go into that interface on switch A that is connecting to host A. We turn it into an access port. We already did that in the previous chapter. Then we add it into VLAN 2. We go to the interface that is interconnecting host B. We turn it into an access port using that command, port link type access, and we add it to VLAN 3. After that, we come to this interface here that is connecting to RTA. then we turn it into a trunk port using the command port link type trunk. Then we go ahead and use the command port trunk allow pass VLAN all. Port trunk allow pass VLAN all. In the previous chapter, I mentioned that when you want a trunk link to be able to carry all VLANs, frames from all VLANs as tagged frames, then you use the command port trunk allow pass VLAN all. So after creating those and specifying the types, the port types, we can go ahead and now subdivide this particular interface G001 on RTA into two sub-interfaces. So we want to create sub-interface that and sub-interface that, and we assign them these IP addresses respectively. So that one and that one there. So let's see how that is done. So in RTA, we can tell we are in RTA through this particular prompt. So in RTA, how we create a sub-interface is by simply typing the keyword interface, the name of the interface, the number of the interface. Then we add a dot. So dot 1. So that is how we create a sub-interface. Once we get into that sub-interface, we can do a number of things. The very first thing we're supposed to do is to specify the .1 queue termination command. So .1 queue termination VID2. So what does that do? So that does two things to this particular interface. It does two things to that particular interface. Number one, it will remove the VLAN tag from the frame and forward this packet via layer 3 routing. So when it receives a tagged frame, so it's receiving a tagged frame from the switch. The switch is sending a tagged frame. It will remove that particular frame, that particular tag, and forward it using the IP header, using the network layer header. That is using the IP address. So remove the tag, then forward using the IP address, rather than forwarding using the layer 2 header. Because this is a layer 3 device, it cannot forward using a layer 3 header. So that is what it will do. Now, other than that, if it receives a packet, that is supposed to be sent out, so for a packet that is supposed to be sent out from that particular interface, then the port will add a tag to that particular frame before sending it out. So what does that mean? So if we are sending a packet, to this guy, then we send it to this particular router via that sub interface, then the router, before sending it back to the switch so that it can be delivered to host A, it will actually add a tag to that particular, at this point here, before sending it out, it will add a tag, and that tag will have a VLAN ID of 2. So that is what that command is used to do, .1 queue termination, to either remove a tag and forward using IP, or to put a tag and forward now to the switch so that it can be delivered to that particular VLAN. Okay. So after that, You also need to, as I've said earlier, you need to configure an IP address for that particular sub-interface. So you use that, and the other command you're supposed to be aware of is the ARP broadcast enable command. ARP broadcast enable command. Now the ARP broadcast enable command is used in order to enable broadcasts to be forwarded to this sub-interface, broadcast packets, and especially ARP broadcast packets. Otherwise, as we know, usually the router will simply discard any broadcast packet that it receives from a particular interface. But when you do this ARP broadcast enable, then it ensures that the sub-interfaces can be able to process ARP broadcast packets in order to enable devices on different VLANs to learn their peers' MAC addresses. So that is what that command is for. Whatever we are doing here on this sub-interface 1.2 are the same commands that I've explained up there. So once we do that, let me go back. So before we do this, if we ping host A and host B, we will not be able to get a reply. It will not be successful because they're on different VLANs. But after this configuration, if we ping host B from host A, we should be able to get a reply. So we do a ping and we should be able to get a reply. So 0.00 packet loss. Okay. So we can either use a router or a layer 3 switch. Now, most of the time in our networks we'll use a layer 3 switch due to a number of reasons. They're a little bit cheaper, and as I said earlier, switches forward a little bit faster compared to routers. Their efficiency is higher. Their forwarding efficiency is higher compared to routers. Now, whenever you use a switch, a layer 3 switch, you'll need to configure what we call VLAN interfaces, also known as VLAN ifs, a VLAN if. So you need to create a VLAN if for each VLAN and assign it an IP address. And therefore, that IP address is what will be used by the hosts as the gateway. So we can see that for VLAN 2, we've created a VLAN if 2 with an IP address of 192.168.2.254/24. So these particular devices will use that as the gateway. So when they want to send a packet to host C or D, which are on a different VLAN, they have to go through the VLAN if. They have to go through the VLAN interfaces. VLAN if are used by each VLAN as a route gateway. So let's see how that is configured. So we want to configure VLAN ifs on switch A. So first of all, we create the two VLANs using the VLAN batch command. So VLAN batch 2, 3. Then after that, we go into a particular interface like gigabit Ethernet 0/0/1. We change the link type to access. We add it to VLAN 2. Again, we go to this interface G002. We change the link type to access, and we add it to VLAN 3 using the port default VLAN command. After we're done with that, we can now create the VLAN interfaces. So how do we create a VLAN interface? We type the command interface VLAN if 2. Interface VLAN if 2. Then after that, we do IP address. We assign it an IP address. So IP address 192.168.2.254/24, like that. Then we quit. Then we create the other VLAN if. So interface VLAN if 3. So these 3 here will be associated with VLAN 3. These 2 here means this VLAN interface is for VLAN 2, like that. It will be used as a gateway for VLAN 2 and VLAN 3 respectively. Then again, you assign it an IP address. So once you do that, really you're done. So once you've done that configuration, now host A can be able to ping host B. So when you do the lab, you should be able to see this live. So that is the end of this chapter. It was quite a brief topic. I hope you've been able to get something from it. So can someone help us in reading the first question?
What is the purpose of the .1 queue termination VID VLAN ID
VLAN ID command. Has someone?
Okay, it has 2 main purposes. Whereby where a port receives a VLAN packet,
yes.
it removes the VLAN tag from the frame and forwards the packet via
yes.
layer 3. The second one is for a packet supposed to be sent out, the port will add a tag to the frame before sending it out.
Very true. Thank you very much. Then what is required to be configured on the switch to allow VLAN traffic to be forwarded to the configured sub-interfaces? On a switch, what is supposed to be configured in order to allow VLAN traffic to be forwarded to the sub-interfaces of the layer 3 switch or router? We need to configure a trunk port or a tagged hybrid port. So don't forget that. We need to configure a trunk or hybrid port so that it can be able to carry frames from all the VLANs. Okay, so thank you very much, ladies and gentlemen. That is it for today. Asanteni sana.